Hello, I'm Professor Lee, work at the Department of Industrial and Information Systems Engineering, Sequential University in South Korea. Today, my subject of this presentation is sequential pattern mining for clustering customer orders with an alternative process layout in the smart factory. This study discusses clustering the customer orders with the same or similar process layout using a sequential pattern mining technique. We present similarity measure to evaluate similarity of two process layouts, and also we present mathematical formulations for integer programming to solve the problem of clustering similar route. We use sequential pattern mining techniques to cluster customer orders and determine the alternative layout related to customer orders. These studies propose two sequential pattern mining algorithms to cluster customer orders. In the smart factory, we need to respond quickly to changes in the customer demand for various product orders through the life cycles of the product. In contemporary industries, we try to improve management and technology for our customer, materials, quality, marketing, and etc. by using smart factory. A smart factory should be operated based on big data, artificial intelligence, the Internet of Things, and etc. In this presentation, we discuss clustering the customer orders with the same or similar process layouts using sequential pattern mining technique. In this study, we propose a similarity measure to evaluate similarity of two process layouts, and also we present mathematical formulation for integer programming to solve problem of clustering similar layouts. And also, we present two sequential pattern mining algorithms. First algorithm finds the frequent layout patterns and clusters customer orders based on the similarity of process layout, facility, and tools. The second algorithm determines frequent layout patterns based on the frequency of customer orders. In recent years, there has been a lot of research and investment in smart factories. However, it is mainly focused on the hardware, Internet of Things based on the telecommunication equipment, and information technology-based system integration. In smart factory, we build an autonomous factory by combining data integration and digital technology through the entire value chain. The autonomous factories can facilitate delivery of raw materials and parts, and also can improve the quality of final product and productivity of overall factory operations. Moreover, it is possible to reduce the costs required for entire life cycle, such as customer order, product planning, design, and so on. There have been not enough studies for simplification of operations and process in smart factory. There have been numerous studies for sequential pattern mining, especially for biology area, clustering, tourist, a prediction method for maintenance, clickstream patterns, and intrusion detection system using sequential pattern mining technique. Conventional sequential pattern mining finds subsequences in a sequence database which commonly appear in several sequences. Traditionally, most sequential pattern mining algorithms aim to describe sequential patterns in the sequence database by mining entire database to obtain the set of results. Conventional algorithms scan sequence database and find a set of frequent sequence patterns according to the user-defined minimum spot value. The static database can be handled well, but there may be limitations or impractical in solving real-life applications. As you know, Many studies have been conducted to describe sequential pattern, but there haven't been enough studies yet on clustering route processes with alternative route in the smart factory. The clustering is known as the NP complete problem, and the sequential pattern mining is NP hard problem when it is considered on the worst case complexity. So it is impractical to solve NP problems directly in practice. This study presents heuristic to solve these problems. To define the problems and formulate the problems, we present some notation on these pages. K is the set of customer odd numbers as a set of integer between 1 and m. And sub I is a set of alternative process route of customer order I. N is the set of all alternative process route. R is the set of process route pairs. F sub I is the frequency of customer order I. That is the number of the odd of a given type. And also we define matrix I and matrix J as two binary process vectors of the process matrix to represent process route for customer orders I and J, where elements A suffix ILM can have either 1 or 0. If process L of order I is processed by immediately before process M, it has 1, otherwise 0. Now we define the process route using directed network G. The network includes the set of nodes and the set of arcs. For example, consider process route of customer order I and J in figure 1. In the process route of customer I has 4 nodes according to 4 processes L, N, or P. And also process route of customer order J has 5 nodes according to 5 processes L, M, N, or P. Process L of customer order I is processed immediately before process N, and process O is processed, and so on. Hence we get binary process vectors of the process matrix. For the customer order I, the matrix I is like this. Transposed matrix, since the elements A, I, L, M equals 0 and A, I, L, N equals 1 and A, I, M, N equals 0 and I, N, O equals 1, and so on. So the same way we can get matrix Ji like this. Now I'm going to introduce similarity measure between process route with alternatives. Similarity measure delta sub IQJR means the similarity value of process route I, process route Q of customer order I, and process route R of customer of J. This includes similarities of process sequence and resource of processes. The similarity measure represents how much two process route Q and R are similar. The process route similarity measure is this part. And the other part is similarity of process resources. And first part is represent the degree of how many identical pairs of process appears in the two process route, Q and R. Alpha value represents the number of pairs of two consecutive processes included in both orders I and J. Beta value is used to represent penalty that represent the number of pairs of two consecutive processes that existed only in route Q but does not exist in the route R, and vice versa. Chi is a weight to impose the relative importance of alpha value compared to beta values. The process similarity measure represents a degree how processes of two routes are similar. Here, epsilon value is the number of identical processes included in both routes Q and R. Gamma is the total number of processes in both routes without redundancy. Psi is a weight to impose the relative importance of epsilon value compared to gamma value. The weight W1 and W2 are introduced to impose weights considering the relative importance of similarity of two routes and the similarity of processes. Sequential pattern mining, considering process sequence, can be represented in M-partite graph. The process selection problem is to find the maximum similar measure value in the M-partite graph. Figure 2 shows a 3-partite graph for 3 customer orders, order 1, 2, 3. Customer order 1 has 2 alternative route P1 and P2. And also customer 2 have 2 alternative process P3 and P4. And customer order 3 have alternative P5 and P6. Now we mathematically formulate the problem of finding 2 or more route patterns for 0-1 integer programming. The objective function maximizes the overall similarity value of a route selected. We have 6 constraints here. In expression 3, we ensure that one or none of the alternative route for a product of customer orders are selected for alternate of the other orders. Constraint 3 ensure that the one of or none of the alternative route for product for customer orders are selected for alternatives of the other orders. In expression 4, it is to ensure that one of none of the alternative route for customer orders are selected. Constraints 5 and 6 impose consistency, and constraint 7 and 8 ensure integrality. You can use a software with any simplex-based procedure to solve the model formulated in these pages for integer programming. The formulations are concise and can solve a small size of the problem well, but with a large amount of data, writing code for 0-1 integer programming could be time-consuming to use like Windows software. Hence, we propose 2 heuristic algorithms to solve in a reasonable of time, which find sequential patterns considering process route. The algorithm 1 is based on the grid sequential covering approach. The algorithms in these studies are repeated as many times as wanted to cluster sequence patterns that cover the desired portion of the production sequences. The algorithm simplifies the problem solved by removing the cluster orders corresponding to the alternative route assigned to the cluster from the considering target. This algorithm finds frequent patterns of process route based on similarity of two routes. Algorithms begins with a similarity measure matrix. The number of iterations of algorithm depends on the threshold value theta as a minimum spot that is specified by the user. The larger threshold value, the less frequent patterns. On the other hand, the smaller threshold value, the more frequent patterns in the cluster, and more time to learn the algorithm. Hence, the setting of the threshold value should find the appropriate value depending on the nature of the problem. Now you can see algorithm 1. Now we apply data in table 2 to the algorithm 1, and we have 5 custom orders in the example. Each custom order has 2 alternative routes. To run the algorithm, we set the threshold value theta 0.2, and we set weight W1 set 1, W2 set 0.5. From the algorithm 1, we obtain 2 clusters. First cluster includes first custom orders route B, second customer order route A, and fifth custom orders route A. So we get the process route pattern B, C, A, D in sequence, and also second cluster including 3B and 4A. So process route pattern is B, A, C, D in sequence. Remind that we should have a similarity value between process route before running the algorithm 1. Okay. Now you see the algorithm 2 in table 4. Algorithm 1 can be used if all of customers' order frequency are identical. We use algorithm 2 when an individual custom order frequency is different. Although the customer's order route is the same, the frequency can be different. Algorithm 2 also simplifies the problems solved by removing the customer orders corresponding to the alternative route assigned to the cluster from the set of route candidate. Algorithm 2 considers both similarity of two routes and the frequency of each route. This algorithm also begins with the similarity value between the process route and use matrix F and use frequency matrix. So at the first step, we prepare frequency matrix between two consecutive processes of all alternative processes and define threshold value as a criteria, which is defined by the user. At the step 1, it searches for a pair of two consecutive processes, the most frequently used on all routes, and continually search the next most frequently used process. So it iteratively adds the process route with the most undiscovered element to the solution set in the step 1 to step 3. Through the steps 1 to step 3, it repeatedly adds the process route with the greatest number of uncovered elements to the solution set. To analyze two algorithms proposed, we coded the clustering algorithm for mining process sequences patterns with the Microsoft C++ on Windows 10 and run the programs on a personal computer. The performance analysis of these studies, we generate 18 datasets. 18 datasets are randomly generated on the uniform distribution state. The number of customer orders, number of process alternatives, lengths of processes are uniformly distributed integer in the some intervals. Table 5 compares 18 solutions by the algorithm 1, and in this table we have optimal solution by window programming and objective function values by program 1. In algorithm 1, the number of frequent process law pattern is mainly depend on the threshold values as minimum spot value of similarity. As the threshold value is increased, the number of frequent route pattern is decreased. That means the number of process routes that are deleted from candidates table of customer order is increased. Conversely, as the threshold value is decreased, the number of frequent pattern is increased. Now, let's see the relation, the running time, and threshold value in the algorithm 1. As the threshold value increased, the target data of the actual sequential pattern mining are also reduced. So, the running time is reduced as the threshold value is increased. Now you see frequent sequence patterns to the threshold value of algorithm 2. As the threshold value of minimum odd frequency set by user increase, the number of frequent route pattern rapidly decreased. On the other hand, there is slight change in the running time as the threshold value increased. The threshold value is frequency of customer order. This figure shows the running time to threshold of algorithm 2. The threshold is the frequency of customer order. Okay? Figure 7 shows the relation of running time and the number of clusters. It shows the changes in the running time as the number of total clusters generated by algorithm 1 and 2 increase. The running time of algorithm 1 increase more than the running time of algorithm 1 as the increase from about 200 clusters in the range of more than 300 process routes. Figure 8 shows the change in the running time of 2 algorithms as the number of customer orders increases. With about 1,500 customer orders, there is a real difference between 2 algorithms. The running time of algorithm 1 is more increasing than the time of algorithm 2, since it takes time to evaluate similarity between the process route of the customer orders and search the similarity value for each iteration of algorithm.
Figure 9 shows memory usage as the number of customers increase. Algorithm 1 use about 0.1 gigabyte to process about 4,500 customer orders. On the other hand, the memory space used by algorithm 1 is rapidly growing from the more than 4,200 customer orders, since it needs the space to keep similarity matrix of a process route for each iteration of algorithm 1.
In contemporary industries, many engineers emphasize the needs of the smart factory. And there is no doubt that the introduction of smart factory will gradually spread. However, there has not been enough research on strategies and methods for operating smart factories. This study shows an example of how data mining can be contribute to the operation of smart factory, and showed two algorithms to cluster production orders by finding frequent sequential patterns with similar production. For large amount of data, we apply the algorithm to the Hadoop systems that can handle large amount of data. This study simplifies the process routing of manufacturing processes, which can reduce a variety of manufacturing resources and can increase the sharing of resources. In the future study, we will take into account the relative importance of each customer orders and identify customer order patterns that can yield company's maximum profit and reflect it the production plan. If you have any question or you need further information, give me an email and then I will show you more information and answers. Thank you very much.